So, let's say, what could I be asked about sequences? So let's try and go right back to basics. Right? Let's not go straight in at any point. Let's think, what was the first thing? So you'll need notes open. Notes open to read or notes open to write this down. Okay? This is what happens when it comes to an assessment. You've got to think, well, surely you've made these lovely notes. You put all your work into them. You've got to use them, so you need to go back to them. And instead of me saying, right, now study this, you should be able to go back to and go, I need to study all of this stuff. So what do you think, what was the first thing I asked you to do? Well, just what was the first thing that we were working on doing?
Arithmetic.
So we talked about arithmetic sequences. Okay. What do we know about arithmetic sequences?
When you take away the two numbers and the two first numbers and the two last numbers, they all equal the same.
So what do we say? It has, so arithmetic sequences have a
Same difference, common difference.
a common difference. There you go. So they all have a common difference. So if you've already got this in your notes, you don't need to be writing this again. All right? They all have a common difference. And you've said, show that it is arithmetic by doing what again?
By taking away like any of the first numbers.
So if I said to you, do U2 subtract U1, that will equal D. Would that make sense to everyone? Yeah? It should be the same as if I did U5 subtract. Anyone? U4 will also give you D.
Oh, because U is 1.
Not because U is 1. So for instance, an arithmetic sequence, give me an example of an arithmetic sequence, Taylor. Any that you like.
1, 3, 7.
So what would be an example of showing that this was arithmetic?
By taking away the 5 and 3
Equals
2.
2.
And then you could also take away the 7 and the 9 and 7.
So 9 take away 7 equals 2. 11 take away 9 equals 2.
Yeah.
So, and that led us to a really, really simple thing that we could be asked to do in a test, which is,
Naming what?
that's not the simplest thing actually, naming it, or
Finding the rule.
that's
What's
not
the
simplest,
difference?
definitely. Pardon?
What's the difference?
No, because you could, actually that would be what you'd have to do to be able to do this thing, but
Oh,
sort of-
just to add like a couple more.
yeah, just add a couple more terms. So do you remember probably one of the first things I asked you to do was write the next two terms? And how do you do that? Well, you find the pattern, you find the common difference, and you just keep applying it, yeah?
Yeah.
So that's something, so you have to be able to find the next terms. You also, like you've already said, finding the next terms is alright. What was the next thing that we then looked at doing?
Ratio.
let's stick with an arithmetic sequence yet, but you're right, we did do ratios and that was a different type of sequence, but let's stick with arithmetic sequences and say what else do we have to be able to do with arithmetic sequences? I think you've already said it once.
You can't take the or you can't subtract.
That's something, when we think about a common difference, we don't, technically, I mean, you can do it. You can say it's always subtract, subtract, subtract. That's fine. But the common difference is what you add on every time. So if you are adding, but the number goes down, the sequence goes down, you know what you are adding must be a negative number. Okay? So we could say, do we have a negative common difference? All right? Do we have a negative common difference? And then after we've thought about that, what was the next really sort of the next stage, the skill we needed to learn how to do? You've already said it once. Nope, let's stick with arithmetic.
The sequence, no, the
Find the
formula. Wait.
Find the rules. The rule.
find the rule. Find the rule for the,
Sequence.
what was it called? Nth term, yeah, that's it. And what do we mean by the rule for the nth term? Yeah, so we're looking for un equals, but what do we use the rule for the nth term for?
To see what you have to times each thing by, each number by.
No, because I think to get the rule you'd have to have done that. Maybe this is something we need to just check up on. Do you know how, can you remember how to find the rule for this sequence, by the way? Go on then.
You do 5 take away 3.
So 5 take away 3, we've done that, so that's the 2.
So it would be 2n.
So we get 2n.
And then you do 3 subtract 2.
So then you go for 3, subtract 2 to give me 1. So then it's
Plus 1.
plus 1. Okay, that's one way of doing it. Just to remind you though, that this term 3 is u1, u2. What was this one here? u0, and it's not a term in the sequence, but you've used it to find the rule. Okay? Was that alright? You remember doing that? What if the sequence was going down? Hey?
You would
Add it to go back up, and what would the rule have? A negative. Okay? That's why I like to think of it more of we don't subtract, because that makes people think, well, what goes in front of the n? So if we always add and it's either a positive or negative, you just put that number in front of the n. Now there's another way of talking about that and explaining it, but we haven't done it yet, but maybe next year you'll go through it. So there's a rule for the nth term. What does that enable me to do?
Makes you find this sequence easier
Yeah? In what way?
by like finding what number goes next.
Well, do we have to only find the one that goes next? Because if I do the common difference, I have to do all the terms in the sequence, don't I? I have to go for the next one, just keep adding 2. But when I've got a rule for the nth term, what does it now enable me to do?
Just
Well, what it means is I can now find any term I like. So, for instance, if I want to know u8, what do I do? 2 times 8 plus 1, which is 17. I could equally find u101, and I don't have to keep counting, do the next. I can just go straight to the 101st term. And how do I find it?
2 times
which is
203.
good, 203. So I know that the 101st term is 203. All right? So that's why I want to find the rule. So I no longer have to keep continuing the sequence. So if I wanted, initially you were told find the first 5 terms. However, quite often in test questions, part A will be find the next 2 terms. Part B will be find the 20th term. And you've got 2 ways to do it. You can either keep going all the way up to the 20th term, all right, which is fine, no problem whatsoever. You just write, we see students with long lists of numbers, get to the 20th term, absolutely no problem. The issue is time, you run out of time. You'll get the right answer, but that's not a problem. Part C, however, though, is find the 101st term. And I have seen someone keep going all the way up to 101. But you know the problem? They lose count. So they do it all correct, but stop at like 99 or something, or go to 102, or, you know, they lose count, which one's the 100, and they can't be bothered to go back and count all their numbers to check they've got 101. Yeah? So having the rule, they don't tell you, you see, then it will be now find the rule for the nth term, would be part D, for instance. Or yeah. Now that leads us to some other questions that can be asked. Okay?
But why don't they just do that? Didn't their teacher teach them how to do that?
I'm going to say the same to you the next time you don't do something. I'm going to go, didn't I just teach you the correct way to do it?
Yeah, but
People forget, don't they? You forget. You try and, I mean, there's nothing wrong with trying to solve the problem however way you've got. Yeah? When you're sat in a test or an exam, you've got a problem to solve and no one to help you. Just solve it, whatever way you can get. You know, you want to get that mark. The only trouble is if you think this question is taking 10 minutes for 1 mark, it's not worth it. You might as well move on to other things, Haji.
Sorry.
Recording that. So there's another, we're still on arithmetic sequence because this is the kind of level most of what you're going to be doing is. Okay? There's some other things that I could ask you. For instance, these are the 2 kind of top level ones. I could say to you, is 406 a term in this sequence? Alright? Yes or no?
no.
With a reason, I would want to know. So that would be a perfect type of question to ask. Another one, which would be along the same lines, would be, let's say, which term in the sequence is 35? So very similar questions but written differently. Any ideas? So just to remind you that, so we're still working on this 2n plus 1, so un equals 2n plus 1. So first of all, is 406 a term in this sequence?
No, because if you look at it, every one has ended in an odd number,
Right?
not an even one, and 206 is
Potentially. However, there is an issue with that statement.
It could be wrong.
You've only looked at a few examples.
Oh,
Now that's a perfectly reasonable way to start. Yeah? Everyone has always ended in an odd number. And actually, there is a reason for that, which is, if we add 1, alright? But that makes people think it always ends in an odd number.
Well, 5 plus 1 is 6.
Okay? And the reason why this case it will always end up in an odd number is because we have to do 2 times something. And when you do 2 times something, you always end up with a even number. So then you add 1 and you get an odd number. So in this case, if you were to give that argument in full, right, that would be a reasonable argument. I'd probably give you the mark, but you'd have to give that in full. So for instance, I would be saying, because you times by 2, you get even, but then you add 1, you will always end up with an odd number. 406 is not an odd number. But that's quite a long-winded way of answering it. There is a better mathematical way.
Just
For things like this, how many times do you recommend we work it out, 3 or 5?
Good question. This goes into something called proof. How many times do you have to do something to prove it will always work? In fact, the answer is a trick question because you can't prove something is going to happen by doing it more times. You can suggest it's more and more and more likely, but you can never prove that it will always happen. Because I could just say, oh, but there might be one out there that doesn't, and maybe that's it. Yeah? So your answer of, if I multiply by 2 then add 1, I will always end up with odd, that's a proof. That's a reason that can't be argued with. Does that make sense? Doesn't matter what number you start with, if I multiply by 2, then add by 1, the answer will always be odd. So 406 can't be. Now that is one possible answer for this question. However, that doesn't work for the second question. So there is, remember I said there's the same kind of method. And this is it. I'm going to go to the second one first and then see whether you can apply it to the first one. Which term is 35 in the sequence? Now, just a tip, if it tells you 35 is a term in the sequence, don't write and say 35 is not a term in the sequence. Okay? Because it will be. So if you write it's not, you've lost your marks immediately. Yeah? Which term is 35?
17.
How do you know?
Because I did 35 subtract 1.
Okay, so what do we write first? We do our algebra, don't we? You're doing the algebra. So we actually write 2n plus 1 should
Times two.
equal 35. And we need to solve for that. Yeah? So that's our algebra work that we've been doing, yeah? So go on then.
So I did subtract 1.
So you subtracted the 1 first.
And then
2n is
34.
34.
You divide it by 2.
So divide it by 2 gives you 17. So I know which term is it?
17.
The 17th term. So 35 is the 17th term. So that's your algebra skills coming into play. Any ideas then on the previous one what we could do differently than say about the odd number stuff? No? Same thing.
Oh, so you
2n plus 1, does it equal 406? That's what we're using. So we're using our nth term. So what do we do? Minus 1. 2n equals 405. Divide by 2 gives me 202.5. And what's the problem with that? Yeah. N cannot be a 0.5. It must be whole. Okay? Or I should say an integer. So for that question, I would love to see the answer, this written out, and then just say n is not an integer. That would be the most effective, efficient, time saving answer. N is not an integer. N is not an integer. That's all I would need to read, along with this working out. Okay, I don't need to write a sentence. I'm showing that I understand in the most simplest way. Now, can you see how, if you'd have written out your, well, I have to multiply by 2 and then I add 1, that will always end up being an odd number. There's a lot of writing for that, and you would only get those marks if you covered everything. So, for instance, it wouldn't be right to just say, when you add 1, you get an odd number. Because if I'd have multiplied by 3, not 2, that's not true. Does that make sense? So you've got to be careful. So that's the most ideal way. Okie doke. So that's the kind of stuff that you have to be able to do for arithmetic. Do you think you'd all be able to do all that sort of stuff? So find a rule. Obviously this was quite a simple rule, but you've got some others in your textbook to work from. But they're the kind of questions at the end that you're going to have to be able to answer. Alright? Okay. Are we ready to move on? What was the next type of sequence then we did look at? The what, sorry? It's not a ratio sequence. It had a different name. Okay, so we looked at geometric. We didn't look an awful lot at geometric, but we did look at it and say, what does it have? Has a common ratio rather than a common difference. Okay? So give me an example of a geometric sequence. Anyone?
2, 7. No.
No. I'll give you an easy one. 2, 4, 8, 16, 32, blah, blah, blah. Okay? How do I know it's geometric or show that it's geometric? Because we do 4 divided by 2 is 2. 16 divided by 8 is 2. So we have a common ratio. Okay?
What does it say for?
Now, do you remember we said that when an arithmetic sequence goes down, we add a negative. When a geometric sequence gets smaller, or goes down in value, remember we don't divide, we always multiply by something. So this one is always multiply by 2, multiply by 2, etc. So if I've got a different one like, what should I do? 18, 9, 4.5, 2.25, and so on. What would be the common ratio? So what do I multiply by?
Negative.
We do exactly the same thing. How do you find the common ratio? Nine divided by 18, which equals? It doesn't.
1. Negative.
It doesn't, does it? There's no negatives. We were working on this earlier. It's not 2. 18 times 2 is not 9.
If it was 2, then 18 would be top.
Exactly. What's 9 over 18? What does it look like that we were working on first thing?
0.
5, no? So we multiply by a half. So my common ratio is not divide by 2, it's times by a half. Do you remember that? Remember saying divide by 2 is the same as times by a half? Divide by 3 is the same as times by a third. Divide by 7 is the same as times by a seventh, and so on, yeah? So your common ratios might be fractions. We don't divide, we multiply. So we did a bit of work on that. We didn't do too much on geometric stuff. There's more to be done on that, but you can wait till next year. What did we then do after geometric?
Quadratic.
Okay, so then we looked at quadratics, didn't we? And what do you know about quadratic sequences?
It has 2 lines of difference.
Okay, so exactly. So if we go back to this arithmetic one, linear sequence, we did our line of difference. So we found our common difference was always +2, okay? And we found that the first line of difference was where it was common, okay? So that was my first line of difference. So that made it a linear or an arithmetic sequence. However, if we had one like 2, 5, 10, 17, 26, and we did our lines of difference, we would notice that that's +3, but then it's +5, and then it's +7, and then it's +9. So it changes. Okay? So my first line of difference is different. But if I look at my second line of difference, it was always +2. Now that helped me know that if it's +2, do you remember what that meant? UN was going to start with n squared. Because do you remember you take that number and you divide it by 2, and that tells you how many n squareds. However, this sequence is not an n squared sequence. So what do we do? So I want to know what UN equals for this line. So I've decided it's going to have an n squared. So do you remember saying, well, what if it was n squared? What would the sequence be? So I put n is 1, 2, 3, 4, 5. So n squared would be 1, 4, 9, 16, 25.
You add 1.
So we add 1. So I'm thinking I've got to add 1, because to get from there to where I want. Now, do you remember it might not always be add 1 or add 2? Sorry, it might be add ends or that kind of thing, yeah? Here's a memory test for you. What is this sequence called? What's that sequence called? The triangle numbers. Well done. And do you remember off the top of your head the rule for the triangle numbers?
It's 1/2 n plus 1/2.
No. But you're so close. Because it's not linear. Because it's +2, +3, plus.
No, it's
plus 1/2.
So it's a half n squared and a half n. That was the rule for the triangle numbers. That was a useful one to try and remember. Another probably simpler one
Square.
is the square numbers, isn't it? So the square numbers,
Is half
1,
plus half.
what are the square numbers? 1, 4, 9, and what's the rule? Really easy, just n squared. Yeah. Right. So n squared because you take n and you square it. That's what the square numbers are. Yeah. All right. So they were some useful ones that we looked at. Can I just ask you then, just this triangle number, if it's a half n squared, what is the second line of difference going to end up being? Plus 1. It'll be plus 1 every time. And you could check that out if you like. Right. So for this, I know because of the half, it's going to be a second line of difference will be plus 1. Yeah. Alright. Now we haven't done it together like with me, but I did ask you to have a look at the questions which were actual physical patterns. Did you manage to do that? So for instance, if you have a pattern like this, so it's like a matchstick pattern. Do you remember from your maths investigations days?
Oh yeah.
So that's the first pattern, the second pattern, the third pattern, the fourth pattern. So for instance, would you be able to tell me the rule for that pattern? The number of matches?
I don't do matches.
4n.
So we have to, let's add them up. So we've got 4, 7, 10. What happens each time? Just adding 3. That should help you straight away. So the rule will be 3n, well done, Tasia,
Plus 3.
plus 1.
Wait,
Because how many matches are there? So that's because what we have, if you think about it, 3n plus 1, if n is 1, that means we've got 3 there, 3, 2 is 3 there, and then another 3 there, 3 lots of 3, 3, 3, and then 3, and then every time you've got 1 more. Okay? So hence it's 3 lots of, or n lots of 3 matches plus 1. Okay? And your method that you had before still works. If you went to 0, what would it be? You'd take 3 matches away and you'd be left with the 1 match. But that's not part of my sequence, but that gives you the plus 1, doesn't it? So if we count matchsticks or anything, we just get a pattern of numbers and we can use it. So there was a nice pattern I saw actually, which was like this. It's 3-dimensional, and it's looks a bit like this. All right. Actually, I'd have to find the question. It's not going to work at the moment. It was a nice one where it had blocks building up in 2 different ways, and it was going to become a quadratic. I'll try and find it on the screen for you. All right, so generally, that's our sequences topic. Any particular comments anyone wants to make about that? I think the only thing we haven't touched on is if you're given, let's say un equals n cubed plus 2n squared plus 2, and I said write the first 5 terms of the sequence, you'd be okay with that? Yeah? No? Why not? You would just do U1 equals, U2 equals, U3 equals. What would U1 be? 1 cubed plus 2 lots of 1 squared plus 2, which equals
So n would be
1 plus
4.
2
Oh,
plus 2 is 5.
5.
Yeah? Because remember the issue that we have had, you
Yeah,
do
but
n cubed and then you do n squared. You don't do 2 times 1 squared, yeah? You only do the 1 squared, the 1 cubed. So my second term would be 2 cubed plus 2 times 2 squared plus 2. So 2 cubed is 8 plus 2 times 4 is 8 again, plus 2 is 18. Yeah? The third term would just be 3 cubed plus 2 times 3 squared plus 2. 3 cubed is 27 plus 2 times 9 is 18 plus 2, so the answer would be 2 plus 18 makes 20. That's nice, isn't it? 47. Alright, so just remember it's this whole, that number, and then for this kind of one it's only that bit that gets squared. Alright? Am I keeping them?
Wait.
So that would be how, that would only be the first 3 terms. So you're probably going to need your calculator, aren't you? Just in case you get one that has to be done like that. So when you have this test, it's you can bring your calculator. Alright?